So lab 7 talks about the conservation of mechanical energy, and basically what this lab is mainly about is, calculating velocity, mass, potential energy, kinetic energy, and of course mechanical energy. And energy is basically the ability to work, and it comes in various forms, and it is always calculated in joules. So mainly I'll be figuring out, the mechanical energy, which is the sum of potential energy and kinetic energy in a system. And as you can see at the bottom, I underline right here what it takes to find your kinetic energy, which would be half times mass times velocity squared, where velocity is instantaneous and mass is always calculated in kilograms. So in the first part, I'll be calculating the mass, kinetic energy, potential energy, and mechanical energy with velocity. So the formula for potential energy would be U equals mass times gravitational force times your height. And these are just the procedures that I will go through and show how you figure this out. Okay. So in the first part of this, I'm gonna just show you right here. So the mass will always be on the smallest, and I'll play him from 6 meters height. And as he goes down, as you can see, the potential energy goes down as the kinetic energy goes up. As you can see, they are inversely proportional to each other. And the velocity is 11 meters per second squared. And that shows you of the ramp. Now, I'll put him at 6 meters height free fall. And as you can see, it still touches 11. And as you can see, the thermal energy goes up because he just hit the ground at full force. And as you can see on this graph, I calculated the potential energy and the kinetic energy, which would be 50 times 9.8 times 6, which will give you 2,940 joules of potential energy for both. And for the kinetic energy, you would do 1/2 times 50 times 11 squared, which will give you 3,025 joules. And as you can see, the kinetic energies and potential energies are the same. And that's mainly because there's no friction involved in it, and there's only really gravitational force that is acting upon it. And that's how you figure out the first part. Okay, and this is the second part of the first lab. Well, not the first lab, but the first section. So now I'm going with a larger mass. And as you can see, with the larger mass, your potential energy would be much greater than a smaller person. And I'll drop him again. And as you can see, the kinetic energy bar goes up as the potential energy bar goes down. And you see you have 11 meters per second squared from the ramp. And I'll drop him again from 6 meters. And this, you get the same numbers. So then you would come and you would calculate your potential energy and your kinetic energy using the same formulas from the first part, and you would get the same numbers. And that's because only gravity is taking place and the ramp is frictionless. Now for number 1, does the work done by gravity depend on the path taken? No, because even with taking the ramp, both of the energies are equal. Okay, and for number 2, gravitational force is conservative, meaning that the total force done is independent of the path taken. And for example, if an object would take a loop path, the total work done by conservative forces would be 0, because it only depends on initial and final positions. And for number 3, does the speed of the skater depend on mass? No, because the forces acting upon it would be the same, and the only thing that would change our potential and kinetic energy, and that's only because of the mass. And that's basically how you do part 1. And on to part 2, which would be kind of the same thing, but you would have to calculate from different points, your potential, kinetic energy, and mechanical energy, and also your speed. So on to part 2. Okay. So for this one, you go to playground, and then you would have this chart right here. So then you would get him right here, and then you would drop him, and you would calculate the speed, which would be 9 meters per second. And to get your potential energy, you would do 50 times 9.8 times 6, and you would get 2,940 joules of potential energy. And then for kinetic energy, you would do 1/2 times 50 times 9 squared, and you would get 2,025. And to find your mechanical energy, all you would do is add up your potential and kinetic energy, as you can see right here. And as we go to part 2, right here, you would basically just place him right here. And as you can see, he doesn't really move. So that's why your kinetic energy would be 0. But you would have potential energy because he has height. He's not fully on the ground. So if he was fully on the ground, then his potential energy would be 0, as you can see in part C. Well, in point C, where his height, speed, potential energy, kinetic energy, and mechanical energy is 0 because he is flat on the ground and he is not moving at all. And for number 1, the ratio of point A and point B would be 1 to 5. And that's basically because not only is the potential energy greater, but point A also has kinetic energy. And the ratio shows that a change in height affects a lot of the energy that takes place over a path. So for number 2, is the mechanical energy conserved between point A and B explained? It is because the skateboard has a velocity, which made it move, even though gravity does play a part in it. It had to go down from somewhere. And number 3 is the mechanical energy conserved between the 2 points, points C and B. No, because there is no movement between the 2 points. Even though point B has potential energy, it stays on the ramp and doesn't move because he basically has no velocity, and the velocity can't take him from off the ramp. So this is basically how I did this part of the lab. And these are just questions based off of the lab right here. So the lab was mainly about calculating the different potential and kinetic energies, and of course adding them to get your mechanical energy. But what is energy? Energy is the ability to work. Everything needs work to function, and the various forms of forces known as energy are used to calculate everything that goes on, especially movement. So number 2, what is the difference between conservative and non-conservative? So conservative forces are forces that do not remove mechanical energy from the system, while non-conservative forces do remove mechanical energy from the system. And an example would be potential energy for conservative forces, and air resistance and kinetic friction for non-conservative. And the principle of conservation of mechanical energy would state that if an isolated system is subjected only to conservative forces, then the mechanical energy is constant. And that's basically what I used to figure out this bottom part. And so to find the velocity, you would basically take, to find the velocity of each point, you would take the velocity squared plus the gravitational pull times your height for each point, and you would get, of course, your velocities. The only reason point C is greater than point B is because your height is times 2 of C. And so for number 4.2 is, if mass was doubled, would the speed increase, decrease, or remain the same? It would remain the same because the forces are still remain are remaining the same. And it also includes that a frictionless roller coaster, which means that no friction force is taking place. So basically, you can conclude from this graph that the greater the height of the roller coaster, the more velocity it will have. And even if mass would change, it would remain the same because it is frictionless and the forces acting upon it would be the same. And that's basically what happens in Lab 7 of mechanical energy.